During my practical implementation of a classification model, I realized that there should be a separate data set for the model performance testing. What I generally do, I divide dataset into three parts: training, testing and the validation, and test the model's performance on a validation and the test set. Generally we do these approaches. But just think in a different way. If your dataset is not uniformly divided into some faults, or you don't know which classification model you have to use for your particular given problems, then how you will deal in such scenarios? Just to understand better for a classification model's performance, you have to know some better approaches that is known as k-fold validations. This k-fold cross validation itself suggests that you have to test your model performance on a different faults by dividing data into the multiple faults. So here, if I am talking about k-fold cross validation, so k means any number of faults. Generally we do as 10 faults, but for a better understanding, let's assume it as k equals to 3. Now, let's say data set size is 100. So what I will do here is I will divide 100 data size to the 3 faults into the equal number. So 33, 33, 33, something like that. In this 33, I will divide these if first set to testing, remaining set for the training. Now for the other one, second 2 sets for the training, next set for the testing, by maintaining the uniformity. So what will happen, the test set which is present in the first set, that will never repeat again for the testing for the next batches, right? I will show you practical implementation of the k-fold cross validation, and that is very important if you are working on a classification model. Recently I was going through a problem statement for my one of the client where I was dealing with the image dataset. In this image dataset I was about to predict true positive and true negatives, but suddenly I faced few issues where model detects false negative cases as well. And here we require a cross validation approach where before deploying the model to the production, we have to understand what went wrong and where we can improve the model performance by accepting the approach of the k-fold cross validation. There could be stratified cross validation for dividing the dataset into the uniform fashion. So we should not lack any particular classes to one folder or other folder. Let's say you have three categories of data and or patterns. So in these three categories of patterns, data would be divided in multiple folds by having all such categories. So your model should not get biased for a particular single category. Okay, we'll see how we can do this practical of this k-fold cross validation. Thank you.
Subscribe now and press the bell icon. Never miss.
K-fold cross validation, I have imported the required libraries as well as the models on which I am going to test the performance of different model on a given data set. Now I have imported three models: logistic regression, SVM and the random forest classifier. For this particular problem statement, I am using the predefined data set, that is the digits, and I am loading that data set. Okay. Now here what I did, I just divided my data set into the training, testing by having train test split, and here I pass this data digits.data train and digits.target as the test one. So it will divide data into x train, x test, y train, y test into a ratio of based on this test size 0.3 or 30%. Now the first model here is logistic regression. So I have defined this logistic regression by passing this parameter, or if you want to see the parameter, you have to see what actual parameters this logistic regression accepts. Okay, so here are a list of parameters which you can utilize according to your need. So here I just used two parameters, solver and the multi-class. Now I did lr.fit and passing the train. Fit means for the training the model, right? X train and Y train. And for testing the model, what is the actual score on a logistic regression reference point, I just call this a score function and pass this test data set, and you can see the model accuracy is 95%. So logistic regression says for your given data set my accuracy would be 95% or my score would be 95. Now I just want to see the performance of the SVM, support vector machine. Okay, let me create a reference point of SVM by having this model imported SVC, and I'm just passing gamma equals to auto. These are also parameter like this logistic regression. You can see what all are the available parameters which you can utilize. All right. Same phenomena we are just going to use for this SVC as well. Now instead of this LR reference, I will just use SVM and I will hit it just to see. So SVM says I can give the highest accuracy as 43% or my score would be 43 for your given data set. Alright. Now let's test this random forest as well. So let's create a reference variable for random forest classifier, and let me provide number of trees. So n underscore estimator, let's say it's 10 as of now. All right. Same two lines for model testing and training, but instead LR I will be using RF, this reference point of random forest. Hit and execute. Now random forest says I will give you the 93%. But now let me tweak this parameter. Alright, if I give the number of trees 40, this model says I will give you 95% accuracy. Okay, here we will see k-fold cross validation. Let me import the required libraries. That means I want to divide my data set into three parts. Now, for your better understanding, what I will do here is I will just taking a very small data set. Let me see kf dot split and I will pass only digits. Alright. For train underscore index and test underscore index. In kf split this one. So here what I will be getting, I will be getting the indexes of the training and testing. It's test underscore index. So basically it will give me the iterator. Alright. Let me print the train index comma test index. Now you can see here is 3, 4, 5, 6, 7, 8. This data set or this first batch, within the first batch, this particular indexes would be considered as a training part, remaining one would be as a testing part. Now you can see here is 0, 1, 2 is already occurred or already part of the testing in the first iteration. Now never get repeated for the testing part. in the next batches. So you can see here the first one is 0, 1, 2, now it's 3, 4, 5 and 6, 7, 8. Alright, this was the basic example. So this example just only for your better understanding. Now we will use this k-fold for our digit recognition purpose. For that, let me define some function. By using that, I will be getting the score of my model. So if you can see here, what I was doing, I was just doing the rf.fit rf.score. Above, what I was doing, svm.fit svm.score. So instead of writing every time, let me write a custom function that will accept the model, training data set and the testing set, and it will give me the score of that particular model. All right. Now let me write some code where I will be using this k-fold cross validation technique, and instead of that I am using the stratified k-fold. What stratified k-fold will do, it will divide the patterns of a data into the uniform fashion. So let's say my data set is having 8 patterns or 7 patterns. So by dividing the data set into the folds, there should not a biasness of the patterns. I mean, the pattern should not get divided into the 1 or 2. So if patterns divided into 1 or 2 and we are testing the data which actual doesn't see in these patterns, right? So that would be a biasness of the model. So a stratified k-fold will do the uniformity. Alright. Now let me import required libraries. I am using 3 models here. First one is logistic regression, second one is the support vector machine, and third is the random forest classifier. So just to get the score out of these 3 models, I'm just creating 3 lists for the corresponding model. So similar way, what we did here, I just pass only the random numbers between 1 to 9 or digits of 1 to 9, a very small data set. Alright. Instead of this, what I will do, let me copy this line. I will just pass my actual data set. So, but instead of kf, I have the reference of faults, right? So faults dot split, and I will pass digits dot data, right? That is the training, and digits dot target, that is the testing one. All right. Same x underscore train, x underscore test, y underscore train, y underscore test. This will be having the corresponding indexes from this iterator of this split. Now what I will do, digits dot data, and here I will pass train underscore index. Okay, digits dot data and test underscore index. Here I will do digits dot target and train underscore index, digits, sorry, and digits dot target test underscore index. The score which we will get for the corresponding model, I will assign to a particular list. So similar way, what we will do, now score SVM and score RF. Okay, here we will be using random forest classifier and here SVC. Inside this SVC, gamma equals to auto. And for random forest classifier, n underscore estimator. So now let me print this metric for a particular model. So score underscore SVM. So SVM says 38%, 41 and 51. Now for this random forest, okay, random forest gives the accuracy on the first training 92%, for the second one 95 and third one for the 94. So this is the better for me. If you want to select a best model for your given data set, you have to test at least 3-4 models. Here in this particular block of code, I am using random forest classifier, right? What I'm doing here, I am just accessing the index of the xtrain, xtest, ytrain, ytest by giving my dataset to the kfaults.split function. Right from there, I will be getting the index. Later on, what I will do here is I will just pass the testing dataset to the model for just calculating the performance of the model. So I just wrote one custom function get score that actually will tell me what is the performance of my model, and this performance of the model for every iteration I will put inside a list that I have already created for a corresponding model, and I'm just printing what is the score of my models, different models score, right? This requires a lot more lines to do such scenarios, right? So here you can see I wrote 10-12 lines of code by testing my model's performance. But is there a way by which we can reduce, optimize such line of code? Yes, let's see now. Now let's see how cross-val score function works. So let me import from sklearn dot model selection import cross-val score. Now we'll see the logistic regression performance by using this cross-val score function. So let me have this cross-val score. Also I'm passing logistic regression and the parameters which already we have passed here, right? Same parameters, and the data, digits dot data and digits dot target. And let's see cross validation equals to 3. Okay, now you can see here is we are getting the metric. See the 89, 95, 90, 89, 95, 90. So after writing 10-12 lines of code, we were getting the score of a particular model, but here cross-val score function within a line we got the output. Let me test this random forest as well. Cross-val score. Now let me pass random forest classifier n underscore estimator equals to 40 and same data digits dot data and cross validation would be 3. Alright, now let's see. So it says 92, 94 and 92. Alright, here I have used this cross validation score function just to get rid of this particular manual implementation where we have to define this list for holding the scores of each model for every iteration and after that just printing. Alright, so cross val score function did within a one line. So thank you very much for watching the video.